Hey there, what's up folks? In today's video we'll talk about the problem that I have given to you in the last lecture of list. But before that, if you want more videos on programming languages, problem solving, data structures, don't forget to subscribe and hit that bell icon so that you never miss the other video. So let's begin. The problem was a Leetcode problem named toSum. In this, we have given an array of integers nums and an integer target, and we have to return indices of the two numbers such that they add up to target. Here we may assume that each input would have exactly one solution and we may not use the same element twice. And we can return the answer in any order. For example, we have nums 2, 7, 11, 15 and the target is 9. So we return 0, 1 because 2 plus 7 equals 9 and these are at indices 0 and 1 respectively. So nums 0 and nums 1 equals 9, so we return 0 and 1. Next example, if nums is 3, 2, 4 and target is 6, so we can see that 2 plus 4 is 6, so we return the indices of 2 and 4. And in the third example, we have 3, 3 and target is 6, so we return 0 and 1. Okay. Here we have given the constraints, that is nums.length should lie between 2 and 10 to the power 3. Nums I should lie between minus 10 to the power 9 and 10 to the power 9. And target should also lie between minus 10 to the power 9 and 10 to the power 9. And here only one valid answer exists. Okay, so let's see. For example, the given list is 5, 1, 3, 6, 2 and the target element is 9. Then you have to print 2 space 3. There are a couple of ways to solve this problem. We will start from brute force solution and then gradually optimize the solution. So let's see. Let's just imagine that how would you do it if it was in real world. We will choose first element from the list and try to make a perfect match iterating over the list. And in the same way, we will check for each pair of the list, and if that matches to the target value, we'll print it. And we will do this until we can't find the perfect pair. So let's see this with the help of example. So here we will check for each possible pair until we get 9. We will start from 5 and check it with the remaining elements of the list. So we check 5 with 1. 5 plus 1 is not equal to 9, so go ahead. 5 with 3. It is also not equal to 9, so again go ahead. 5, 6. No, it is not equal to 9, so go ahead. 5 with 2. And then we will check 1 with all the remaining elements, that is 1 with 3, 1 with 6, 1 with 2. 1 with 5 is already checked in the case of 5, so we'll not check it again. And we'll continue with the whole list. And if we find the pair whose sum is 9, then we will print and return. Otherwise, we will just continue with the list. Okay. So what we are basically doing here, we are iterating over the list and finding the perfect match. So here you can see that for this iteration, this value is constant and this is changing. For the second iteration, this value is constant and this is changing, and so on. So we need an extra iteration for each single iteration. That is, if we start iterating from 5, we again need a loop which starts from 1 index ahead of 5 up to the entire list. So for each single iteration, we need an extra iteration, and we can do this by using nested loop. The outer loop will start from index 0 and move up to the last index, and the inner loop will start from outer loop plus 1 and it will move up to the last index. And we'll check for each pair until we find one. If we find the pair, we will just print it and return. And if not, then we'll just continue. And if the pairs are not found in the whole list after the entire iteration, we'll just print none. Okay. So let's see this in code. We will make a function and we will pass the list and target value in its parameter. So let's see. In Python we define function by using def keyword and the name of function def print index. Let's call our list nums and the target value nums comma target. And we will use for loop for I in range length of nums and for j in range I plus 1 up to length of nums. Remember, in range the end index is exclusive, okay? And we will check if nums j plus nums I equal to target and I not equal to j. We have to make sure that I is not equal to j, okay? Then we'll return I comma j. And if element is not found after the iteration, then we'll return none. Okay, let's check if our function works or not. So we'll call print index and we will pass a list. Let's pass this list 51362 and target is 9. Here we are returning the values of I and j from the function, so we'll print it. And now running. Okay, we are getting 2 and 3. So we have 3 and 6 at index 2 and 3, which equals to 9. So we are getting the correct output. You can check for more test cases. So here the time complexity of this function is O of n square because we are using nested loops, and space complexity is O of 1. This is not the best optimized solution. So what can we do to optimize it? Let's see. What if we sort the array? Okay, so our sorted array looks like this. And yes, we can avoid using 2 for loops. How? The alternate of using 2 for loops is using 2 pointers. Our first pointer starts with starting of list and second pointer starts with ending of the list. Let's see with another example. Let's say we have this list 3, 9, 2, 1, 5, 4 and the target value is 9. So firstly we'll sort the array so it becomes 1, 2, 3, 4, 5, 9. Let the left pointer be L and the right pointer be R. And we will check if value at L plus value at R is equal to target. If the value is less than target, then we will increase the left pointer by 1, and if the value is greater than target, then we will decrease the right pointer by 1. And if the value is equal to the target, we will return the values of L and R. Okay. So let's see. Here L is 1 and R is 9. So 1 plus 9 is 10, which is greater than target value. So our right pointer will decrease by 1. So now our right pointer is at 5 and left pointer is still at 1. So 1 plus 5 is 6, which is less than 9. So we'll increase left pointer by 1. Now left pointer is at 2 and 2 plus 5, it is 7, which is less than 9. So we'll increase left pointer by 1. So now L is at 3. So 3 plus 5, it is 8, which is again less than 9. So we'll again increase left pointer by 1 and it is now at 4. So now 4 plus 5 is 9. So we'll return the values of L and R. Okay. And we will search until left is less than right. So we will use a while loop and our condition will be while left is less than right. Okay. we simply return the values of these elements. So in this case, we will return 4 and 5. Here we are sorting our list. So the old index will not be maintained in the new list. So we can't return index, okay? So in this case, we'll simply print it. So let's see this in code. We will define a new function, print index, and we will pass nums and target. Firstly, we'll sort the list, nums.sort. We will initialize left and right pointers. So left is equal to 0 and right is equal to length of nums minus 1. Now we'll use while loop, while left is less than right, and if nums left plus nums of right is less than target, then we'll increase left pointer by 1. So left plus equal to 1. If nums of left plus nums of right is greater than target, then we'll decrease right pointer by 1. And else, if we don't have these two cases, then definitely nums of left plus nums of right is equal to target. So once we found the elements, we will return from the function. Okay. And at the end, if we don't find the values, we'll simply return none. So let's check this. Checking for a previous test case only. Running this file. See, we are getting 3 and 6 because our target was 9. Okay. So here, what will be our time complexity? Let's see. To sort the list in the worst case, we require O of n log n time. And here while loop will require O of n time in the worst case if element is not found. So our overall time complexity will be O of n log n. Okay. And space complexity here is O of 1 because we have not used any extra space here. Okay. So here we have optimized the solution a little bit. We have come from O of n squared to O of n log n. Okay. Now let's see if we can do better. So here we have seen two ways to solve this problem. Although the second way will not work if you have to return the indices only. So the next optimized approach we will see in the next part of this video. Until then, try to find the optimized solution which takes O of n time. So see you there. Thank you.